Hey class, this is the continued lecture of where we left off from the previous recording. Today I just want to show you more about select statements. In the next recording lecture, I will go over all the inner join, left join, right join, and the union all, and show you how to write them, okay? But for this one, if you recall, to make a table, you would do create table. Alright, then you give it a table name. Let's just say car or vehicle, okay? Open parenthesis, close parenthesis with a semicolon. Then for this, you would give it all the column names, so you would have name. Whenever you have it, you want to give it a data type. For name, it only wanted to have 25 bytes. The easiest way to think of bytes, if you're not familiar with how their unit are being stored, is that it's literally gonna make sure that even if whatever you store don't add up to that much of memory, it's still going to append white space to take up those memories. And then years of creation or release year. And this would be number. Remember, in Oracle, we don't have integer or decimal. What we have is number, and number is usually 4 years, so I just have 4. Okay, once you have it and you run it, it's going to create a table vehicle for you. And if you recall, doing a select all from vehicle will show you everything that vehicle currently has. And if you notice, I didn't really press this at all. I just highlight the SQL statement and I press Control Enter. That will execute the statement for you as well. That's the shortcut for this tool. And because I have not insert anything, the two columns don't have any data. Okay, so if you remember, we need to insert something. Insert into is always the statements that you start with. Insert into what? Insert into vehicles. And I want to insert into both of the columns that this table currently has. Okay, name would be, let's just select the Honda Civic, and it's released in 2018. Alright, you see one row inserted. Now if I run select all, I want to have Honda Civic 2018. Okay, I want to show you first the word distinct and what exactly would distinct do. To really do this, I'm going to insert another record, name, release year. If I run select all, you see that I have two of the exact same record, Honda Civic. The reason why I was able to insert I was able to insert duplicate data into the same table is because my table don't have any don't have any unique constraint, as in it don't have any primary key, and because it doesn't have any primary key, I can insert as many of Honda Civic in 2008 as I want to. If I just do it a couple more times, right, you see that I have a lot of the same record appear multiple times, or 6 times to be exact. Now, this is when I use select all. If I just do select distinct all, it's only gonna show me Honda Civic in 2008. Why? It's because I'm saying the distinct keyword is pretty much give you back distinctive record, right? Record that are unique. Because in this table, I only want to display the tuple or the combination, one record. I only want to display one unique tuple. The distinct keyword automatically remove all of the other duplicates for me, and it's only return one record because it is saying that, hey, for all of the record you have, there really only one unique record. The way distinct work is that the SQL database engine will first run this SQL statement. If we run select all from vehicle, then it would apply the function of distinct into it. I'm just taking a distinct so you know the sequence of operation, what run first. when you have a statement like this, they're distinct on will run last. It's going to run select all from vehicle first. Then it will apply the behavior of distinct into this result set that you have. And what distinct does, it will return the unique tuple for you. Okay. Now, if I only want to select this thing, say name, then it's not going to, again, it will first select all the name from vehicle. So that means Honda Civic gonna appear 6 times. Okay, look here. Honda Civic appears 6 times. If I am to run the statement now with the word distinct, you see that Honda Civic only appeared once. So distinct is used to get back the unique record in your table. Okay. Now, something that also very similar to distinct. Oh, sorry. And you cannot put distinct behind the column. You have to put distinct before the columns. Okay. Select distinct, meaning, hey, whatever I'm about to select next, I only want a distinctive result of the columns that I want to displayed. Okay. Another SQL reserve word that behaves similar to distinct would be the root by. Okay. These two behave the same way, but the way you use them are different. For distinct, all you have to do is just put the word distinct in front of all the columns that you want to select. So select distinct name, release year, right? So you that. For root by, what happened is you no longer use the word distinct. What you would do instead is you would first select all the columns that you want to select. Alright, so I want to select name, release, year. Right, and you will still have your from statement. This is where the difference will come in. Your root by will appear after your from. Okay, so basically for the root by, you would finish your select statement first, meaning you may add in the where and then you filter by whatever column over here. Alright, but the root by will always come at the end. Alright, so root by name and release year. As you can see, it's now only give me back the unique tuple that I have in my table. Okay, the easiest way to remember root by is that whatever column you select, you need to have that column in the root by, because you are saying, hey, I want to group my record by this column, right? Always when you group something, whatever is similar, they're gonna get grouped into just one category. So this pretty much will filter your data set and only return the unique record. Okay. Another cool thing with that you can do using root by and not with distinct is the SQL function count. Let me just show you this for select R from vehicle. Right, we all know what this is gonna do, right? So it returns 6 records. There is a convenient way to write a SQL statement that will let you know exactly how many records you have in your table using the function count. Just give it some space. So count. This is how you should write count. Okay, so count and then open parentheses, close parentheses. Whatever you want to count by, you would put it in the middle of these parentheses over here. So in this case, I want to do a count of every single columns in the table. So for each of the rows, get back all the columns and do a count on them. I don't think I explained it very well. So hold on. So the count will count how many rows your table have, right? This over here is pretty much just what is it gonna count by. That means if you select all, then all the column make up one row, and it's only gonna count how many rows it has. It doesn't matter what the column you select, it's only going to give you the number of row count. So in this case, if you only want to count how many total record name appear, you would just do this and it would still give you 6. But usually why, right? Why only count one column? If one column and all columns are the same, then you want to use asterisk to get back all the results set. Okay, now let's insert some more record. I don't want to insert Honda Civic anymore. Let's just say Honda COV, right? And I'm gonna insert it 3 or 4 times. Doesn't matter. Then Honda Fit. All right. Let me make it 2018. Now this is a brand new Honda Fit. Then Honda Odyssey. I think I spelled Odyssey wrong, but don't mind. Alright. Now if I do a select count from vehicle, it's gonna give me the total number of records I currently have in my vehicle table, which is 17. And if you don't believe it, you can just write select all from vehicle. As you can see, 17 record. Okay. Now, what something that group by can do, but this thing cannot do, is I can pretty much write a SQL statement that tell me, hey, tell me how many times a specific record appear in this table. So for example, I want to know how many times Honda COV appear in this table, right? So what I would do is that I would first filter the table for just Honda COV. Select all from vehicle where name equal Honda COV, and remember it's case sensitive, right? Whatever you want to search for, the column is not case sensitive, but the actual value you want to filter by is case sensitive. If I run this, you see that I'm supposed to have 4 Honda COV, right? So if I'm gonna write my using the count, I can do something like this. Select name count from vehicle where name equal Honda COV. It's gonna show me just one row, which is Honda COV, and the number 4 because this name appear 4 times in this table. Oh, sorry, because I use the word count, I need to use group by. That's right, I forgot, my bad. Alright, see? So what I'm saying is, first select whatever column you want. In this case, if you want you can how many times a specific record appear in your table, you would filter by the table. Then you would tell your SQL statement you only return the uniqueness, give you back only the unique record. This count will count how many times that unique record appear. So I want to select name where name is Honda COV, and I want to only display the unique record for Honda COV, but I want to count how many times Honda COV appear in this table. I would do this. Okay. So that's how you do count and group by. If you want to use distinct, there isn't really a way for you to write distinct and it will return 4 rows for you in this format. A lot of the report that you do, all people really care is, hey, how many of this SKU did I sell, so how much money did I get? And what you would do, you would just select the uniqueness of the SKU number, and you would pretty much time the price by the number of times the SKU appear, right? If you want to change this a little bit, say now I just want to see, let's see, how many times Honda Fit appear, right? I would just simply change this to Fit. It's pretty easy, I already write it for you. You can also now put back in the release year. It's still not going to change anything because if you put release year over here though, notice what's going to happen. It's telling you not a group by expressions. Why? Because remember what I told you, whatever column you have in your select statement, you need to include them in the root by as well. Okay, you don't need to include aggregate function or any built-in function in your SQL in the root by. But if you want to use any built-in function, then you have to use root by. You're gonna use distinct. Some of the other built-in function you have is sum, subtract, sum. Not really returning anything because this don't make any sense. You want a sum. The sum only work if you want to get an aggregated values. For example, let's make a new table and let's just call it sales item, right? And I would have item for charge 2, give it 20 item, and price, right? And it would be number, and you can have up to $1,000. No. Actually, make it 6, 2. Meaning I can have up to 6 digits. 4 of them have to be decimal. 4 of them have to be 2 of them want to be decimal digits. All right. Make this. Okay. Now insert into table sales. What do we want to sell? We want to sell, let's say, a mocha frappuccino. And the price is, I believe, $5. I can write like this just fine because what's gonna happen when it insert into the table. Just gonna make it 5. It's not gonna display the decimal value, but you can have up to 2 decimal value just fine. Now if I want to insert one more mocha frappuccino, because I don't have any uniqueness in this table, I can insert as many of the same data as I want to. Alright, you see that for, let's just say this, for today I sold 6 mocha frappuccino. Right, and I'm asking you to write me a SQL statement that will give me the total amount of money that I earned today just by selling mocha frappuccino. Obviously, you cannot use the count. Count will only show you the number of times the record appear in the table. Right, so let's write this really quick. Count from sales root by item. You can see all I'm telling you is mocha frappuccino appears 6 times, right? Now, this doesn't just tell you, oh, okay, but I want to know how much did it cost, right? This is where you can use another function by sum. Now, you can look up the function yourself. Just know that if you use any function, you would have to use root by. You cannot use distinct. You can only use distinct if you're not going to have any function, or if you're not going to use any built-in function in your select statement. Okay, so now I'm going to write a SQL statement that give me the total amount of money I earned for selling mocha frappuccino for today. Root by item. As you can see, it's telling me that, hey, I made $30 selling mocha frappuccino today. The sum, literally what happened is, okay, first it's gonna select the uniqueness of the unique item in table sales. That means they're gonna go to mocha frappuccino and it's gonna see that this appears 6 times. That's just what the root by do, but it's only displayed 1. The sum will sum each of the price each time this record appear, and because it's appeared 6 times, it's gonna show you 30. Okay, it's $5 each. Cool. Then you can look for more function on Google and just practice them by yourself. Another cool thing is now you can actually tell is to display both the number of times this item appear, and the total price that you're able to sell the item for. So this mocha frappuccino appeared 6 times and I made 30 bucks on it. Remember alias, right? So I don't want to have this. I can just say as item sold, right? Number item sold. This is the alias, because what the heck is accounts? For people that understand SQL, we know what they are. But if you are to provide a report to your leadership, senior managers, CEO, this is very unprofessional. So you want to format them into a nicely formatted Excel sheet or record or report that you can send to your upper leadership, right? Something like that. Total revenue. Ta-da! Now you have this item, mocha frappuccino, the number of time you sold this item, and the total revenue you made on this item. Okay, cool. Now even one thing, even if you give an alias to item, let's just call it SKU. Where in your root by, you still want to root by the column name, not by the alias name. Okay. Now watch, if I try to root by alias, it won't know what I'm referring to. Okay. It's saying SKU is not a valid identifier. So root by, you have to use the actual column name. Okay. Pretty cool, right? So that's distinct and root by and counts, right? These are useful for report purposes. Okay. Okay. Now if you remember about all the alter statement that I told you about, in your create table, just call it what do you want to make? Maybe snacks. Okay. Now if I want to create a uniqueness record, you would have to make a primary key. To make a primary key, you have to first pick what are the potential candidates that can become your primary keys. Is it just going to be a single key, or is it going to be a composite key? Let's start out with just single key. So for single key, I'm simply just going to call it ID, okay? And ID is going to be number, and this is integer, because this will only be integer. We never have any decimal value. And what I would do, I would put the word primary key right next to it. And I might have snack name, Part2, 20, price, number, 6, 2. Run this. Alright. Now what happened? I just made table snacks. Table snacks will have 3 columns: ID, name, price. Out of those 3 columns, ID will be a primary key, meaning ID can never be repeated. So as an example, value 1, name is Cheetos, price is let's assume, I don't know, 1.7. If I am to run this, as you can see, it's inserted just fine. Why? Because 1 is the very first record in the table, right? 2, even if it's not, as long as this table doesn't have, as long as their column ID doesn't have any other value 1 in it, then this record will be fine. Okay, 1, 2 to 1.7. Now do something different. Oops. Sorry, that's the wrong key. Let's just make it 2. I just want to show you Cheetos and price can still repeat. Why? Because the primary key constraint only apply to 1 column. That means only this column has to be unique in this table. Name and price doesn't. Okay. Right, Cheetos. Now, if I am to insert want, again, even if I do insert with different value, that you call the redux, and somehow it costs the same amount of money, when I try to insert it, you see how, because I have the constraint primary key on the table, the database engine helped me to safeguard against whatever I'm trying to inject into this table. In this case, the database see that ID 1 already exists in this table, so it's never going to allow this value to exist again in this column, because this column is supposed to be unique. Okay. If you don't want to make or declare your primary key this way, you can use alter. And let's just, for example, if I am to use alter, let me just make a new table. Actually, let me just use table sales. What does sales have again? Item and price. Okay. Now I'm gonna add a table called ID into sales. Remember, you are trying to change the structure of the table, and you have to use DDL, data definition language, which is alter. So alter what? Alter table sales. What do you want to alter? I want to add a new column called ID, and this ID is gonna be your primary key. This ID is also gonna be just an integer value. If I am to run this, alright, because you see how this table sales already have record in here. If I am to add ID into this table, it's not gonna let me, because it doesn't know what value to populate for all their existing record in this table. And so basically all the record right now have to be deleted first before I can alter the table, right? Because now I'm applying a constraint to it. That means this record will also change. The value will be the same, but I need because I add in a column called ID, and ID is a primary key. I need to populate the value first before I can populate any other columns. So what I would do, I would delete from sales. I delete everything from the table sales. Then I would add in this additional column, and I would make this column a primary key. Okay, say table sales alter. If I am to select R from sales right now, you see how sales now have 3 columns. And another cool thing is, let me refresh this database really quick. Where's the refresh option? Oh, okay. Go to table, look for my sales table. If you expand this and actually click on it, you get back the definition of this table. And what happened is, because you're in the column tab, it's showing you all the column, and then the item, price, ID. It's also showing you the data type, right? Varchar 2, 20 bytes, number, nullable. These 2 columns do not require any value, but this column does, because this column can never be null, cannot be empty, since it's a primary key. Primary key cannot be null, right? So that's the difference. If you also click on constraints, you see how when you click on constraint tab, when you click on the table, it's all of these columns are just a different part of your table. It's basically their how do I say it? It's not their attribute, it's not the column, but it's more like some other attributes that make up your table. In this case, your table has constraints attributes. This constraint is a primary key constraint. And if you click on this primary key, it shows you, okay, this primary key constraint only applies to 1 column, and the column name is ID. The column position is 1, meaning it is the first column in this table. Okay. Cool. Actually, no, it's not the first column. click on this, display the column that associated with the constraint. It's also show you when this key was last created, who is the owner of this key, who made this key system, because I'm logging in using their username system. Okay, so that's how you can use author statement to make your primary key, or you can make your primary key from the get-go if you already know which column is going to be your primary key column. Okay, now one thing that is different is for composite primary key, meaning you try to make multiple primary key at once. You cannot just do ID comma next column comma next column. No, you would first have to create all your column first. So in this case, let me just drop table snacks. Okay, alright, drop snacks. Drop in snacks will also drop all the primary key constraint on it. Alright, I'm gonna make snacks again. If you want to have a composite primary key right within the create table script, right, you have to make all the columns first. So ID, name, price, and let's just say manufacturer, voucher 2, and this is gonna be a big one, super long, so I'm going to make it 40. Okay, now I have all of my columns. I want to make ID, manufacturer, and name my primary key. What I would do is I would go down here, I would define my constraint, then I would put all of the column that would make a composite primary key within this parentheses. ID, name, manufacturer. Okay, if I'm gonna have this though, now coming back to table design, if I'm already gonna have a primary key with actual column in here, then I really don't need this ID column anymore, right? This ID column was just there for convenience sake. If I don't know which column should be unique, I'm just gonna make a not a natural key, but just pretty much just a sequence object, so that I know, hey, this ID can never be repeated, but the record can be repeated. But if I already know out of all the column that makes sense in this table, these name and manufacturer should be unique, then I really don't need ID. Okay, but that's just table design. That's really up to you. I just want to show you that if you want to make composite primary key, and do it this way. Now it's execute everything. See how I create table snacks? Now if I select R from snacks, alright, show me 4 columns, 1, 2, 3, 4. Okay, now we're going to do the exact same thing again. First, let me refresh my database, especially the demo schema. I will go to table snacks, I will click on it. Right, now go to column, see 4 of them, see how ID cannot be known, name cannot be known, manufacturer cannot be known, because all these 3 are part of my primary key. If I go to constraints, click on the primary key column, you see how now it's showing me that for this primary key constraint that I created, it has 3 columns. Okay, so that's how you make primary key. Okay, if you want to use author table to make your primary key, that's also fine. Let me first drop table snacks. Keep forgetting to highlight. And now I'm gonna create table snacks, but I'm not gonna give it any primary key at the moment. That means my statement in here. Yeah, I just made table snacks. Now I'm gonna use the author DDL syntax to apply the primary key to my table. Now the author table snacks add constraint give the constraint. When you do this, you're gonna alter tables next. And remember earlier, because I was only adding column, I did not have to specify add column. I just gonna give it the column name and the data type. But now I want you alter table and change the structure by creating something else. Instead of making a column, I now want to make a primary key constraint. I would then have to put the word constraint in here. And after constraint, I have to give it a name. Usually, if your constraint is a primary key constraint, just put the word pk in front of it. Right, pk and then the table name. That means, hey, this constraint that I make is a primary key constraint on table snacks. Okay. Then I would now type as the word primary key, and I would include my column. There you go. Alter table snacks. Add constraint pk snacks. And this constraint is a primary key constraint. This primary key is a composite primary key. Consists of these 3 columns. Okay. Now refresh. Click on table snacks. Go to constraint. Okay, to refresh correctly. Hold on. Refresh. Because I specifically named my constraint pk snacks, I'm expecting to see this name when I'm reviewing the constraint of the table. There you go. See how this constraint has pk snack? Did you notice the difference? Earlier, I did not give my constraint any name. So the database engine automatically create the constraint name for me. But now, because I use alter table, I actually have to give my constraint a name. Okay, that's pretty much the difference. Okay, so that's pretty much it for today. So we review counts, sums, group bys, distincts, alter table, create primary key constraint, and just create primary key constraint in general. Okay, make sure you review this. I think these are very important, especially if you want to start out your career as a data analyst. Otherwise, if you just want to be a software developer, these are also useful because now software developers wear multiple hats. We are required to know both SQL and to be able to code. So you should know your SQL syntax well. And knowing this along too would help so much, would definitely help you to land an internship. Alright, next lecture we're going to review foreign key on top of union and all the choice statements.